Well, hello everyone. Let me just introduce myself before just going to the journey. This is Vignesh. I'm the Cloudera certified Hadoop developer, Big Data certified analyst, and I'm the chamber member of IBM's Big Data University. This is a brief introduction of mine. And well, let me just start the journey of big data. Before rushing into the topic, I'd like to just start this with a basic layman discussion. If you consider the data is being generated at large magnitude, and when I talk about the backend, the data warehouse, the ETL processings, and the large databases to store the huge magnitudes of data like Teradata and Netezza, and purchasing the storage from SAN, all these things are making your data storage and data processing as too expensive. And we need an alternative. Of course, this is not so simple as we talked about, because we can't change all your infra overnight. So in order to change this, there should be several drawbacks in the existing storage and processing methodologies, because just because of a simple word like Hadoop, we can't change your infra. So there must be several drawbacks in the existing data storage and data processing methodologies. And let me just share what are all the drawbacks. And number two, a simple example. Consider you have a bank account which was opened somewhere around 2000, and after 13 years, that is in 2013, you approached the bank and you asked them for the past 3 months bank statements, which you'll get hardly in a couple of minutes or at most of half an hour of time. Consider the very next day you approached the same bank and you asked them for the past 10 years bank statements, which you can't expect in the same span as you got your 3 months bank statements, because all your data will be moved to the backend, from which they will start generating some reports which are very much crucial for the organization's development. And in this process of storing your data, transferring your data, and processing your data, there are several drawbacks. And let us just discuss what all are the drawbacks and why we need an alternative, and why that alternative should be Hadoop. So let me just talk about the data storage and data processing literature survey. We know data is too precious, where I classified the data as people's data and machines data. When I talk about people's data, we the people usually generate some data from the social networking sites, e-commerce, online shopping, online reservations, banking, and all the stuff. We usually generate some data, and we the people usually upload images, likes, comments, shares, tags, applications, ads, tweets, whatnot, everything, and all the stuff will generate some data. And machines also generate some data, like your RFID readers, sensors, GPS traces, satellite communications, and your log files. These are all comes under the machines data. And since I just prepared these slides long ago, where the challenge initially was for the organizations like Google, Yahoo, Amazon, and Facebook, because these are the guys who usually deal with large magnitudes of data. But now, this is the problem to almost 90% of the organizations. They are just suffering from large magnitudes of data. They don't know how to handle that. Not only simply magnitude, there are several other factors with your data also. And at last, I just passed a bold statement stating that existing methodologies were becoming inadequate to process such large data sets. Let me just share why exactly I shared it and why exactly I passed that statement. So let me just start the journey with the data storage perspective. Well, when I talk about the data storage, the first and foremost word that will strike away your mind is nothing but RDBMS, which has been ruling the industry from the past 2 decades. But your RDBMS has several drawbacks. Some of them are like, there is a storage saturation limit. Your RDBMS cannot hold and perform well with large magnitudes of data. It can store terabytes of data, and it can't perform at that perspective. And schema on write. Whenever you want to upload the data, in your RDBMS, initially we need to define the schema, and if you get your data other than the schema what you defined, if you get any new field other than your schema what you defined, you can't store that obviously. So you need to know what sort of data you will get in your future, and if you get anything other than that, you can't store that. So that is one of the drawbacks. And above all, there is no support for unstructured data, which is the most sounding stuff. Well, let me just share what exactly unstructured data is. The data on which you can't define any schema comes under the unstructured data simply. Your XML files, HTML files, your log files, your image files, audio files, video files comes under unstructured data. But it was quite unfortunate, about 90% of the data which is being generated is unstructured data. And your RDBMS obviously fail at that perspective. This is regarding the data storage in RDBMS. But let me just talk about the physical storage of disks. We usually purchase SAN storage. We usually purchase the storage from SAN, in which we have been storing the data in FC disks, fiber channel disks, and the latest enhancement is SSDs, solid state disks. Well, we usually just purchase the data purchase the space in 24 TB factor. So the word SAN itself means it is too expensive, because of the switches you use in the SAN are expensive, and the FC cables you use are expensive. And not only storing your data, you usually provide the redundancy for your data also by using RAID levels and something like mirroring, which are expensive. So on average, on the whole, the data storage challenges are point 1. You can't store your unstructured data, and point 2 is there is expensive in your storage. So the drawbacks are there is no support for unstructured data and it is too expensive. These two are the most sounding drawbacks. Let me just share what about the data processing challenges. And when I talk about the data processing, obviously after storing your data in your RDBMS, we usually transfer that to the data processing centers, and where you usually store your data in your Teradata and all the stuff by using the ETL components like Informatica, Golden Gates. And when you just talk about the Teradata is a very good approach to process your data and to store large magnitudes of data, but Teradata has a drawback. Though Teradata can process your data in a parallel way, the block size of the Teradata is only 16 KB, which is very less. And above all, it will not work with normal hardware. They'll require high-end hardware like blade servers and Spark processors to work on, which are expensive. And I need to talk about the RAM also because of the high-end hardware. The largest RAM so far available is of 128 GB. In the data storage, we already discussed that the drawbacks are no support for unstructured data and it is expensive. And the same expensive come into the picture in your data processing perspective also, because of the high-end hardware we have been using. It is becoming too expensive. So far in the data storage and data processing, we have two drawbacks: no support for unstructured data and it is expensive. And let me just talk about the network constraints, because the word network itself indicates that there are several drawbacks. And currently we have been using FC cables, fiber channel cables, in order to transfer your data, through which we could acquire a transfer rate of 16 Gbps at most. I think 16 Gbps transfer rate is not a simple transfer rate. It's huge. It's huge. Though your network could be able to transfer the data at 16 Gbps at largest speed, but your disks cannot read at that much faster. And at this perspective, I need to talk about a simple word called as disk seek time. Though your network could able to transfer your data at this rate, 16 Gbps, your disk speeds are hardly at 250 to 500 Mbps. So obviously they lead to a bottleneck problem. And we usually use any Unix flavors or Linux flavors in order to store your data. And let us just consider I used Unix to store your data at the storage perspective. When I installed Unix, I'll have Unix file system on the disk, in which the block size is of 8 KB. Consider I stored a data of 64 MB. I stored a data of 64 MB in your Unix file system, which will internally consume 8,000 blocks. When in order to retrieve that same 64 MB of data, my disk head need to be moved 8,000 times from one block to another block. And the time taken by the disk head to move from one block to another block in order to retrieve the data back is nothing but what we call as disk seek time. And after all, for retrieving 64 MB of data, my disk head need to be moved 8,000 times. What about the terabytes and petabytes of data? A question mark. Not only that, your network is also expensive because of the FC cables we have been using, and it is ultimately leading to a bottleneck problem. And the overall, till now we did not discuss anything regarding Hadoop or anything else. We just discussed what are all the existing storage and processing drawbacks and why we need Hadoop exactly. Here we have the drawback RDBMS, where you can't store your unstructured data and it is expensive, and this is the place where you will get your bottleneck. This is the place where you will get your bottleneck, and this is the place where it is becoming expensive again. So on an average, the drawbacks in the existing storage and existing processing methodologies, including the network, are: point 1, there is no support for unstructured data; point 2, it is becoming expensive; point 3, your disk seek time; and point 4, your network constraints. We need an alternative eradicating all these 4 drawbacks. So your new technology should not be expensive. It should not be expensive. It should work with cheap hardware, and it should eradicate your network issues, and it should vanish your disk seek time, and it should support your unstructured data also, and that is your Hadoop, which will vanish all these 4 drawbacks. The main reason why I have been focusing much on data is here. I think many of you people, you would have heard about this organization, IDC, International Data Corporation. And according to the IDC statistics, in the year of 2006, the world's data is of 0.18 zettabyte. And in the span of 5 years, that is in 2011, it increased 10 times and came to 1.8 zettabyte. By the end of 2020, they are expecting this to reach 40 zettabyte. Just imagine how many 24 TB hard disks do you need in order to store this 40 zettabyte. And let us just make a simple mathematical calculation. 1 zettabyte equals to 1024 cube terabyte. Let me just make it much more approximate. 1 zettabyte equals to 1000 cube terabyte. That means 1 zettabyte equals to 10 power 9 terabyte. And 40 zettabyte equals to 40 into 10 power 9. That is 4 into 10 power 10 terabyte. By the end of 2020, my data would be at 4 into 10 power 10 terabyte. Just imagine how many 24 TB hard disks do you need in order to store this much of data. Not only simply storing it, you need to provide the redundancy also. How many days do you need in order to transfer this across your network? And how many $billion do you need in order to process this data? The thought itself indicates that we are choosing a wrong path. We need an alternative. That's your Hadoop. And above all, about 80% of the data will be unstructured. And we the people are also generating this unstructured data as discussed previously, where we usually go for like social networking sites. We usually upload your images, video files, likes, comments, shares, tags, applications, tweets, whatnot. This is your unstructured data. And I classified mails as your semi-structured data, where if you consider a mail, we know that it will have to, CC, BCC and from columns. We can define a schema on that. But can you define any schema on your text body? No. And your friend might attach an image file, he might attach an audio file, he might attach a video file, he might attach an XML file, where it is unstructured. But we can define schema on the high-end level like your to, CC, BCC and from columns. That's the main reason why I classified mails as semi-structured data. And usually machines also generate some unstructured data like your RFID readers, sensors, log files, GPS tracers. When I talk about the log files, we usually disable your log files at the server level. Access log files, we usually disable it for the performance issue. But if you have the technology to deal with these log files, you can generate money out of this dump. And that is the place where about 90% of the e-commerce is looking for. Yeah, 90% of the e-commerce is completely focusing on processing their log files, and they are just generating money out of that dump. And before just going to Hadoop, I need to talk about this word, big data. Well, big data is not a technical term. It is not at all a technical term. Any data having several characteristics could be spelled as big data. And let us talk what all are the characteristics to be possessed by a data in order to spell itself as big data. It is volume, velocity and variety. Volume indicates the magnitude of your data, whether your data is at the range of terabytes, petabytes, exabytes or even at the range of zettabytes. Variety indicates whether your data is structured, unstructured or semi-structured. Velocity indicates the rate at which the data is being generated and the rate at which you need to process that generated data. And if you have all these three characteristics, if your data is at the large magnitudes, if it is of unstructured or semi-structured, and if it is at generating at high, fast, we can call it as big data. And it's your Hadoop which can handle this big data in an excellent way. Big data is a problem. It's $1 million question, and Hadoop is the solution to handle your big data. Let me just share, till this moment I have been spelling you that Hadoop can handle big data and Hadoop can overcome all the drawbacks what all we just discussed. Let me just share how Hadoop can overcome all those drawbacks. So whenever I talk about Hadoop, Hadoop has two major components within it, HDFS and MapReduce. And whenever I address Hadoop, Hadoop is always at a cluster level. It's always at a cluster level. And a cluster is nothing but a combination of nodes through a network. And a node is nothing but a computer. So simply, a cluster is nothing but combination of computers through a network. When I install Hadoop on each and every computer, it will simply become a Hadoop cluster. And Hadoop has two major components as HDFS and MapReduce, where HDFS stands for Hadoop Distributed File System. Well, distributed file system is not new. It's not new at all. It's old. But Hadoop Distributed File System is something new, where the block size is 64 MB by default. Just imagine 64 MB block size is not a simple block size. Let's just talk like this. Consider if you want to store 128 MB of data in your Unix file system, which will consume 16,000 blocks to store that. And if you want to store the same 128 MB of data in your Hadoop, it will just consume 2 blocks. In case 1, when you store your data in your Unix your disk head need to be moved 16,000 times. But if you just store the same data in your Hadoop, your disk head need to be moved only 2 times. So obviously the disk seek time is vanished. And since you are storing your data directly in your file system, you can store your unstructured data also. That's the main reason why we could able to store your images, audios, and video pictures, video files in your laptops, because you are directly storing them in your file system. Since you are storing the data directly in your file system, you can store your unstructured data also. You have that privilege. And whatever the hardware you are using, in your Hadoop cluster, each and every computer is a commodity hardware. It's a cheap hardware. That's the main reason why I can install Hadoop on your own PCs on the day 3 of our journey, because your laptop is a commodity hardware, your desktop is a cheap hardware, my laptop is a cheap hardware. Your Hadoop can work on with it. It does not require any high-end hardware like blade servers and Spark processors to work on. And above all, Hadoop is an open source. So obviously your expenses will be decreased because of the low hardware, and it's an open source. And we have another component called as MapReduce, which will process your data which was stored in your HDFS. Which will process your data that was stored in HDFS, not in a simple processing, it's a massive parallel processing. Since you are storing your data and processing your data on the same cluster, obviously network issues will be eradicated. So let me just share here. Hadoop does not require high-end hardware. It requires commodity hardware and open source. So expenses will be decreased, point 1. And point 2, you are storing your data directly in your file system. So you can store your unstructured data also. And point 3, your block size is of 64 MB. Even you can configure it. So obviously your disk seek time is vanished. And since you are storing your data and processing your data on the same cluster, your network issues are also vanished. What else do you need? All your 4 drawbacks are vanished. That's your Hadoop. And Hadoop is the one where it can make data storage and data processing at one hub, and that hub is nothing but your cluster. And it is the fastest processing. Well, this is not what Vignesh is sharing with you. This is the IBM's declaration, where we processed 1 terabyte of pure unstructured data with your RDBMS, which consumed 28 hours to process it. The same 1 terabyte of unstructured data with your Teradata, which consumed 6.5 hours to process it. And the same 1 terabyte of unstructured data with your Hadoop 180 node cluster, which consumed 3 minutes 27 seconds to process it. And the same 1 terabyte of data using the same 180 node Hadoop cluster using Yarn, a latest enhancement on top of Hadoop, latest architecture, which consumed just 1 minute 19 seconds to process it. Just imagine how much faster it is. Above all, we could get all the privileges at cheap cost. That's your Hadoop. This is what I have been talking about. When you want to deal with big data, whatever the data you upload, that will be broken into 64 MB splits, and these splits will be scattered among your nodes of your Hadoop cluster. So your data is already made into blocks, and those blocks are scattered among your nodes. When you want to process this data, you will design a simple computation. A computation is nothing but a simple jar file, which you could design using your any programming language like Java, Ruby, Python, Perl, or even C++. You'll prepare a jar file, and it's your jar file which will travel towards your data. Since this is a node where your data is stored on the hard disks, and you'll have some resources, RAM and processors, and using these resources, you have already data in this. So using the computation what you triggered, using the computation and using your resources, this will process the data what all present in this node, and this is in this node, and this will do in this node. So on an average, it's a parallel processing, and on each and every node, this data will be still more processed in a parallel way. That is the main reason why I call it as massive parallel processing. On a high-end view, it is processing your data in a parallel way. But on each and every node, it will still more process your data in a parallel way. That's the main reason why we call it as massive parallel processing. And I'll delve much more deeper regarding this in the later sessions. Well, this is the Hadoop core concept, where it is easier to move your computation rather than moving the data, and that's what we have been doing here. In the early stages, we have been transferring your data, where it led to several issues. But in Hadoop, your data is already stagnant. It's already scattered and stored in your nodes. That's your computation which will travel towards your data. And it's a massive parallel processing for ease, for the faster processing. And it is easier to deal with small data pieces rather than dealing with big data sets. That's the main reason why we just broke your data into 64 MB blocks, and we are just processing that. And above, you could get all the stuff at commodity hardware, cheap hardware. Well, this is the quite common question what I usually get from from many of the people. That's the main reason why I included that in my slides. Well, majority of the people, they usually ask me, why should I go for a new infra called as Hadoop? Why can't I achieve the same storage processing with the existing methodologies? They mean to say as they would like to purchase several disks, and on each and every disk they would like to just store the data in your RDBMS, and they would like to process all those disks parallelly. Well, they can do that, no problem. It's a very good thought. But what about the disk seek time? What about the data time? Since you are storing your data in your RDBMS, can you store your unstructured data? No. What about the replication? What about the redundancy? To provide the redundancy, obviously it will become expensive. So owing to this, we need an alternative. That's your Hadoop again. Well, I think majority of the people would have heard these words. When you heard about Hadoop, you would have heard this like Hive, Pig, Scoop, and all the stuff, where we call them as Hadoop ecosystem components, where we have almost 18 ecosystem components. Well, when I talk about MapReduce, the people who has a very basic Java knowledge and the knowledge of any other language like Ruby, Python, Perl can work on with MapReduce. They'll write a simple MapReduce job and trigger that, which will consume a lot of time to develop that. But we have something called as Pig, which is almost just like a scripting language, but it has its own scripting language called as Pig Latin. Whatever the script you write, that will be internally converted into a MapReduce job. And no need to worry regarding this, because I'm not from any scripting background, but I have been working on Pig comfortably from the past 8 months. But I'm not from any scripting background. It's the easiest one. And we have something called as Hive. The people who have very basic leverage knowledge of SQL, yes, they can work on with Hive. And whatever the query you write, that will be internally converted into a MapReduce job. And currently, your data is being stored in RDBMS like DB2, Oracle, MySQL, SQL Server, and all the stuff. If you want to import that data to your HDFS, we have an ETL tool called as Scoop, which will import the data from your RDBMS to your HDFS. And HBase is one of the NoSQL database, the most crazy word, NoSQL. Well, when I talk about NoSQL, it indicates not only SQL, where it can store your unstructured data also. You don't have anything like primary key, foreign key, and you don't have anything called as normalization. It's not a row-oriented architecture, it's a column-oriented architecture. And we have almost 150 NoSQL databases, out of which the famous are HBase, Cassandra, MongoDB, Neo4j, Couchbase DB. These are all some of the most famous stuff. And Avro is an ecosystem component to deal with serialized files. And Zookeeper will coordinate all the ecosystem components. And each and every ecosystem component, what I have addressed here, are open source. And your Hadoop itself is an open source. But Can any organization dare to work with open source, that too with new technology, because you can't get any technical support? If you want to build your cluster using Apache, yes, we can build it. You need to download it, install it, configure it, and in the meanwhile, if you just have any issue, no support. In a similar way, if you just work on with any of the ecosystem components, download them, install them, configure them. In the meanwhile, if you have any issue, no support. In the maintenance perspective, if you have an issue, no support. And owing to this, and since this is an open source, you can't expect well-built GUI also for this. And owing to these drawbacks, there are several organizations came forth like Cloudera, Hot&Works, Greenplum, Begin Sites, Amazon, Microsoft, Oracle, Teradata, Intel, HP. They came forth and they just released their own Hadoop distributions. And all these distributions, Cloudera, Hot&Works, and all the stuff, they'll just give you an excellent customer support. They'll give you a very good GUI, and they'll offer you all the ecosystem components as a package. That's your Hadoop distributions, out of which we have almost 12 Hadoop distributions. These are some of the organizations who have been following Hadoop, where when I talk about Apple, I think you all know that per minute 40,000 Apple apps are being downloaded all across the world. And when I talk about Facebook, for every 6 users there is a one Facebook user in the world. But they are just generating huge magnitudes of data, and 2 terabyte of data being generated at New York Stock Exchange market every day. These are all some of the people who are following Hadoop. By the end of 2015, we are expecting about 90% of the organizations should follow Hadoop in order to survive in the industry with the large magnitudes of data. So this is a brief introduction of Hadoop, and if you have any queries, you can fire me with your queries. Well, thank you all for participating.